The Zagros Mountains along the Iran-Iraq border present a tactical nightmare for any pilot. These jagged peaks and deep, narrow valleys provide excellent natural masking, but they also hide an impenetrable network of long-range radars and surface-to-air missiles. This geography creates a severe mathematical problem. Moving slow-moving bombers or rescue helicopters into this airspace means flying into a zone where the enemy can see every movement perfectly. To strip away that advantage, military planners rely on an aggressively complex choreography known as time on target. Cruise missiles launch from escort ships, strikes fire from submerged submarines, and stealth bombers drop massive payloads from high altitude. Despite starting from entirely different distances, these munitions are calculated to impact multiple inland targets at the exact same second. This simultaneous detonation creates a total systemic shock. By overloading the primary defense network all at once, surviving a heavily fortified radar zone becomes a solved equation of precise timing. Timing is reinforced by deception. Before the main strike force arrives, ADM-160 MAL decoys flood the airspace. These miniature drones inject false data directly into enemy screens, swarming the operator with phantom threats. To a technician watching a panicked radar scope, a handful of these tiny drones looks like a massive squadron of incoming F-15 or F-16 fighters screaming toward the capital. With the defense network distracted by the decoys, the airspace is kicked wide open. US and Israeli F-35 stealth fighters can slice through the valleys completely undetected by long-range early warning systems. But owning the radar spectrum creates a false sense of security. Despite dominating the electronic battlefield, a vulnerability rooted in basic physics will turn a routine combat mission into a catastrophic fight for survival. Stealth materials hide a radar cross-section, but they cannot mask the single Pratt & Whitney F135 engine. This engine is one of the most powerful in the world, and during high-G maneuvers, it produces a colossal thermal plume. Instead of using radar, modern air defense networks deploy infrared search and track systems. Specialized loitering munitions like the 358 missile fly in slow figure-8 patterns over a designated airspace, simply waiting to detect that intense thermal output. Passive infrared sensors operate differently than radar. While active radar waves fail to bounce off the angled stealth fuselage, the IR sensor simply absorbs the existing heat trailing behind the jet. Because these passive sensors emit zero energy, the standard warning receivers trigger no alarms, giving the pilot no warning. Stealth technology is entirely blind to the infrared spectrum. This basic physical reality shifts the advantage away from multi-billion-dollar jets and back to relatively cheap, heat-seeking missiles. This dynamic played out when an F-15E Strike Eagle pulled above the Zagros Mountains radar horizon. A proximity fuse triggered a missile hit, causing catastrophic hydraulic failure and forcing the crew to eject into the pitch-black terrain. The ejection immediately activated the Sandy Protocol. With hostile quick reaction forces closing in on the crash site, the mission shifted to an emergency rescue escort. An A-10 Thunderbolt II arrived to secure the area, diving into the valleys. The pilot executed a low-level strafing run, using the 30mm Avenger cannon to shred an approaching enemy convoy. But at this altitude, the Warthog was exposed. The aggressive maneuver placed the jet in the sights of Iranian infantry, armed with thousands of man-pads, Chinese-made, shoulder-fired infrared missiles. A heat-seeking missile shredded the right turbofan engine. Relying on the Warthog's heavy titanium armor, the pilot managed to limp the crippled jet away from the mountains, eventually ejecting over the southern waters of the Persian Gulf. In a few hours, technological superiority collapsed. Multiple highly trained pilots were now scattered across hostile territory, turning a surgical strike into a massive, escalating crisis. At 3:15 a.m., a combat search and rescue package launched. Two H-60 helicopters, call signs Peugeot 11 and 12, pushed deep into the Zagros Mountains, flying well under the radar. As dawn approached, Peugeot 11 finally located the distinctive flash of the A-10 pilot's infrared survival strobe in the dirt. As they flared for landing, the trap sprang. A concealed Soviet-era Zu-23 anti-aircraft gun opened fire from the ridge. This legacy weapon system relies on manual, analog sights, completely ignoring every modern electronic countermeasures the helicopters possessed. Heavy armor-piercing rounds tore through the fuselage of Pedro 12. With transmission lines severed and the crew injured, the pilot wrestled the dying chopper into a hard, controlled crash near Pedro 11. The most advanced stealth-capable Air Force on Earth was now pinned to the dirt by mid-20th century analog guns. Under cover fire from F-35s loitering in stealth overwatch, the A-10 pilot and the surviving rescue crew sprinted across the rocky terrain, piling into the back of Pedro 11. The lone surviving helicopter was dangerously overloaded. With 3 full crews crammed inside, the aircraft was operating entirely beyond its safe mechanical limits. Pulling maximum engine power, the pilot lifted off. They barely cleared the tree line, diving back into the deep valleys to escape incoming fire and race for the Iraqi border. Billion-dollar synchronization and advanced electronic decoys dominate the radar spectrum, but they cannot rewrite the laws of heat and gravity. When technology fails over a mountain pass, the human promise to recover every downed airman becomes the only true failsafe.